As I mentioned back in lesson number 2, oscilloscope triggering is really important, but I didn't want to confuse you with a deep discussion about triggering when we were just talking about waveform scaling. So, what the heck is triggering? Simply put, it's synchronized picture taking. Hi, I'm Johnny Hancock, Product Manager for Keysight Technologies Infinivision Oscilloscopes. After a brief detour to talk about probing in lesson number 3, let's pick up where we left off in lesson number 2. So here's our two waveforms from our resistive divider network. Let's turn off channel 2 and just focus on triggering on channel 1, since that's the source we are currently triggering on. This oscilloscope, every time it triggers, and I'll try to explain what triggering is in just a minute, it captures 200,000 points. That's the memory depth specification on this oscilloscope. It is taking samples at a 2 gigasample per second rate. That's the maximum rate, which means the samples are 500 picoseconds apart. So there are 200,000 points that make up this waveform. And then the scope is updating that very quickly and displaying it on screen. Now, it may look to you like that's just a single stored waveforms, but it's updating very quickly. If I move the trigger level up, as you saw in the earlier lesson, we lost trigger and all we see is a blur of waveforms. Now, what's happening now is the scope is throwing up those 200,000 points in a random location. And so this is supposed to be synchronized picture taking. Now it's unsynchronized display of pictures. Well, you might be able to see this better if I slow our input signal down. So I'm going to change the input. Right now it's a 20 kilohertz sine wave. I'm going to change it to just 5 hertz on the generator. Okay, so this is a much slower signal. I have to change the horizontal scaling in order to see it. So right now the trigger level is above the waveform, and you can see every update of this waveform, but it's not putting the points up in the same spot every time. It's not synchronized. It's putting points up randomly in different locations. That's not what we want. If I move the trigger level back down to within the waveform, then it synchronizes again. This is the synchronization point right at center screen. Let's speed things up again. I'm going to speed it back up to 20 kilohertz, change the horizontal scaling again, get a couple, let's just one cycle on screen now. Now notice, as I change the trigger level, as I move the trigger level up, it looks like the waveform is shifting to the left. That's because the waveform is crossing the trigger level at center screen at a different location on the waveform. So at this point, this is our synchronization point. If I move the trigger level down, the waveform shifts to the right, but we have a new synchronization point right here. Let's put it back in the middle. And let's go into the trigger menu and see what some of the trigger settings are. So over here, remember the trigger section. It may be in a different location on your scope. There's a button that says trigger. On your scope, it may say menu. I'm going to press trigger and then go into trigger type. And it says we're triggering on an edge. If I press that again, it gives some of the different options. It says edge, pulse width, pattern, rise, fall time. These are some advanced trigger types that we're going to see in one of the later lessons that we'll be covering. But we're triggering on an edge of the signal, and that's what you'll be using most of the time. It also says we're triggering on channel 1. We could change that to channel 2, but channel 1 is our trigger source. And it says we're triggering on a rising edge. Now, we can trigger on a falling edge if we like. If I press slope, I could change it to falling, and now you can see this is the falling edge of the signal. This is the trigger level. This is our synchronization point or our trigger point. We'll get into more advanced triggering later during this video series. But in our next lesson, lesson number 5, we'll be talking about better ways to perform measurements using cursors, as opposed to counting divisions and multiplying times scaling factors, which I showed in lesson number 2. Remember, Keysight has lots of technical resources on oscilloscopes for engineering students that you can download at the URL listed on your screen. Go MIT Beavers, and a shout out to my favorite professor and friend at MIT, Dr. Stephen Lieb.